One critical visual task when using Choropleth maps is to identify spatial clusters in the data. If spatial units have the same color and are in the same neighborhood, this region can be visually identified as a spatial cluster. We have developed a methodology that identifies the critical boundary cases that can impact the overall visual presentation of the Choropleth map with respect to spatial autocorrelation. To illustrate our approach, we used the Chicago crime data from 2014. There are 77 regions and 26 types of crime variables in this dataset. For classification, ward clustering has been applied with cluster numbers 5 for 4 variables: robbery, counterfeit, sexual offense, and liquor violence. We will also apply normalization. The resulting classification and the principal component scatter plot are shown. The scatter plot, which shows a PCA view of the feature set, can help users to visually inspect boundary conditions of the projected clusters. However, the silhouette value is determined by the cluster stability and not PCA locality. In order to further investigate cluster stability, the user will select a threshold for the silhouette value to identify spatial units that are near cluster boundaries and may contribute to changes in the amount of visual clustering shown on the map. We adjust the silhouette value to the range of -0.2 to 0.2 . After adjusting the range, units in the map are highlighted. Squares in the scatter plot correspond to the highlighted spatial units. The highlighted spatial units and their square counterparts represent unstable cluster assignments that can impact the visual spatial association. Below, 3 maps are automatically generated, with the middle map being for comparison only. In the bottom left map, we can see the impact of minimizing the effective change, where highlighted units have been relabeled to minimize the amount of spatial clustering. For example, the highlighted unit in the large yellow region has been dispersed as the unit on the yellow to blue boundary has shifted to blue due to its cluster instability. Such an effect may be desirable in map design, as this may help to eliminate the potential for users to identify spurious patterns if the result of the visualization is designed to be as dispersed as warranted by the data. Similarly, in the bottom right map, the effective change has been maximized. We can see a larger yellow region formed by the 2 units that are on the purple to yellow boundary shift to yellow. If we look at this highlighted unit, which is surrounded by yellow colored units, if it was relabeled to the yellow cluster, then it would maximize the spatial cluster. However, that cluster is not a boundary for the element. Users can upload any shapefiles themselves and explore their classifications and boundary elements themselves.